Hello, my Algebra 2 students. It is day 6 of Unit 1, and we're talking about one-to-one functions and onto functions. So those are just little ways that we can classify sets of relations that we know are functions already. So the first part, and we're going to look at an example 1, is saying, all right, consider you have two simple functions. So we've got f of x equaling 2x, and we have g of x equaling x squared. So when it says map the domain from -2, 0, and 2 not map it onto the function, but map this domain using each function and fill in the appropriate range. All we're really saying is domain means here's some x values that we're going to use. So in the domain over here where we are talking x's, if we plug -2 into the function, you can do a little work off to the side. So if we say let's do f of -2, we're just doing 2 times -2, and we would kick out -4. So we can put that over here and say, all right, -2 goes to -4. If you continue that for the other two values, so plug in 0, that would give us 0. And then f of 2, if you go 2 times 2, that's going to give us 4. That's what this would look like. So our range would be the y values that it's then producing. If we do the same thing over here for g of x, so plug in -2 into the g of x function, which means we're plugging in -2 and squaring it. That's going to come out to be +4. Plug in 0. So 0 squared will kick out 0. And then if we plug in +2, square it, that's going to also give us +4. Right? So two different types of functions here. We got a linear, we've got a quadratic. When it says what is fundamentally different between the two functions in terms of how the elements of the domain get mapped onto the elements of the range, what we're looking at over here is that on the left side, every x has its own y value, or each element in the domain maps to an individual element in the range. This is what we would consider to be a one-to-one function. And so when we say one-to-one, we literally mean there's one x for one y. That's it. So we see no repeated x's or y's. Whereas the second example, we've got 3 different x values, but we're seeing only 2 y values in that 4. We've got 2 different x's mapping to that same y. This would be considered not a one-to-one function. Right? And for the exact reason that that y has 2 different x's that match, so there's not exactly one y for one x. We've got like duplicates going on there. And so it still fits being a function, but the fact that we have repeated y values is how we spot that it's not going to be one-to-one. So down here, when it says a function is one-to-one if, the way I'm going to say it is if each element in the domain, so of the x values, matches to exactly one element in the range, and vice versa. So it means exactly how it sounds. 1x for 1y. That's what you're looking at there. Now, there's a reason that we'll talk about one-to-one functions, but baby steps. So when you slide on down here, just being able to identify them. Saying you've got 4 tables given below. One represents a relationship where y is a one-to-one function of x. Determine which one it is and explain why the others are not. So if we just go one at a time, if we're looking at this first guy here, if we take a look, we're looking for no repetition. So the fact that the x's repeat here for 4s and for 9s, even though the y's don't, means this isn't even a function. So if it's not a function, then we definitely can't classify it as a one-to-one function because it's got to be a function first. For the second one, if we look, we have all different x's. If we look through our y's, though, We've got a 1 here and a 1 here. I can't have the two different x's matching to the same y value. So this one we would say is not 1 to 1, and it's because you've got repeated y values. If we look at choice 3, 4 different x values, and we actually have 4 different y values. So this guy should be the winner for the one that is 1 to 1. Put a little smiley face on that guy. The last one, double check. If we're looking at our x's right off the bat, we can see we've got repeated x's again, and you have repeated y's. So this thing's garbage. It's not a function. It's definitely not 1 to 1, obviously, but we can note that it's got repeated x values. If you want to note that it has y values as well, that's perfectly fine. But again, it's not even a function. All right, so it doesn't pass that test for being a function in the first place. All right, moving on to the next page here. You've got a couple graphs to evaluate. So taking it from tables to graphs, when it says consider the following 4 graphs, which show a relationship between x and y, circle the 2 graphs that are functions. And how do you know that they are functions? So take a look and decide which 2 make sense here. I'm hoping that you chose graph 1 and graph 4. Because for it to be a function, they need to pass the vertical line test. And what the vertical line test is, if we remember, is the fact that if we draw a vertical line in anywhere on the graph, it should only touch once. If we draw it in here, it's hitting 1, 2, 3, 4 times. It's failing big time. Same thing for this guy. Hitting twice, that's still enough to say that it fails. Right? When it says of the 2 that you circled, which one is the 1 to 1 graph? Well, where do we not have any repeated y values? So if we take a look at the parabola over here, we can use the x-intercepts to kind of prove our point. We have an x-intercept here at, I don't know, maybe that's x equaling 1 or something. And over here, maybe x is like -3 or 4, something along those lines. But on the x-axis, all the y values are always 0. So whatever this x is, it's kicking out a y value of 0. And whatever x value this is over here, it also has a y value of 0. So this one would not be 1 to 1. Right? Whereas if we look at the one over here and use our x-intercepts as an example, you only have that one x-intercept. And same thing goes anywhere on the line. There's no x value where it's mapping to the same y value. So we can toss out choice 1, and we're really looking at this guy right here. I don't know, maybe we can star it or something. So when it says which one is the 1 to 1, it's going to be choice 4, and it's because there are no repeated y values. So if we come back here to be able to spot that graphically, when we would have repeated y values would be if we actually took and drew in a horizontal line through the graph. If it hits more than once, that's a way to check to see if it's going to be a 1-to-1 function. So here, when it says to determine if a graph, or excuse me, if a given graph is a function, we use the vertical line test, because what you're ultimately checking for is you're checking for repeated x values. And so to determine if it's 1 to 1, you want to first make sure it is a function. So it's got to pass a vertical line test. But now in this case, it's got to also pass the HLT, or the horizontal line test. And it operates the same way the vertical line test does. Does it hit more than once? If it does, then we say it fails. If it only hits once, we say it passes. All right, so using those rules, take a look at example 4 down here. So when it says which of the following represents the graph of a 1-to-1 function. So I need the one that passes the vertical line test and the horizontal line test. So if we're going vertical line test, 1 already fails that. See you later. 2, that would definitely pass, so we can hold on to it. 3 would pass, and 4 would pass. So these guys are all functions. But if we now apply the horizontal line test, the second we draw a horizontal line through, this guy's going to fail. If we draw a horizontal line through, this one's looking pretty good. But come on down and try that last one. We can easily convince ourselves like, nope, that hits more than once. We're getting rid of this guy. This is the only one that's a function and is one-to-one. So choice 3 should be our answer. And fun fact, this would be a little radical function. We talked about restricted domains with those guys, but we didn't focus too much on the graphs. So that's what would actually produce that graph right there. All right, the one at the bottom here, we've talked about absolute value functions earlier this year. They're just talking about the distance that a number x lies from a number on the number line can be represented using an absolute value function. So they're saying how far away a value is from 5 is given by this d of x equaling the absolute value of x minus 5. When it says give an example that shows that d of x is not going to be one-to-one. To be honest with you, because I'm a very visual person, the first thing that I think of is the graph. Right? If we think about an absolute value function, even if I'm not being really specific, I should be thinking in my mind that like y equaling absolute value of x, that's going to be that V shape like this. All right. We'll eventually talk later in the year about transformations and how it will move depending on what you add or subtract in here. But if I get my graphing calculator out, I can convince myself, all right, that this graph, instead of being at 0, 0, would just be shifted over to the right 5 and would look like this. And so it's a really quick way to say like, all right, it definitely passes the vertical line test, but that V graph there would fail the horizontal line test and would not make sense here. All right, so we can say it fails the horizontal line test. Remember those 3 dots maybe from geometry? Therefore, it is not one-to-one. Could we also look at this algebraically? Sure, but maybe that's something we can talk about in class. So an algebraic solution is an option as well. So we'll star that so we remember to come back to it. All right, we just got a little bit more to look at. If we flip on over to the last page of the notes here, on this last page, what we've got going on there, it's saying you've got, oops, let me slide that down there. A function f from domain A to range B is said to be blank for all elements B in set B if there's an element A in set A such that A maps to B. Well, if you go back to the title page of our notes, the title page of our notes said one-to-one functions as well as onto. So this is the onto terminology. So we say that functions are onto if basically for every x value, there's a y value that it's going to match up to. Right? So when it says, in other words, a function f is onto if every element in the domain and range are matched up. Or essentially no elements are left out. It's really easy to see what I'm talking about when you see it in these little like set notations here. So you've got 2 examples shown. The one that says onto, if you take a look in the domain over here, you've got R, H, O, and Q. And in the range, you've got 4, 2, and 5. So like you have 2 being mapped to by 2 different numbers, totally fine. Because every element here is matched up to some element over here. Whereas in the not onto case, all of the values in the domain are being used, but we have values in the range that aren't matched to anything. So there is no x value here that matches to 8. There is nothing here that matches to 1. So if we have little friends that are left out, that is not said to be onto. All right. So we can say that 8 and 1 are not paired up with elements from the domain, which is why we say they are not onto, or it is not onto, excuse me. All right, the very last question. We got to save a little something for class. That will be our recap for class tomorrow. Make sure you've answered any questions in the video, and I'll talk to you guys soon.